Hello and welcome to our lecture. This lecture is a sequel for the previous lecture related to production costs. We're still gonna discuss the costs, but this time I want to address the break-even point and the break-even analysis. Now, if I want to define the break-even point, it is the point at which the total costs equal the total revenue. This means that at this specific point, your business is not making a profit, neither making losses. So at this point, my losses are, my costs are equal to the revenues, no profit, no loss. So I need to know this point because beyond this point, I know that I will be making profits. And before this point, I know that I'm making some losses. So it's very important to know your break-even point so that to know at least this has to be my price so that I do not make losses and I start to make some profit beyond this point. Now, how do I calculate this point? Let's see. This is a graph showing the break-even analysis. This is the break-even point. You can see that it is the intersection of the total revenues and the total cost. They will intersect at this specific point. We will refer to this point as the break-even point. I know that at this point, I have no losses, no profit. Before this point, you see here the red area, I have losses. Beyond this point, the profit will start to increase. So if I want to start drawing the break-even chart step by step, you will see that first of all, in order to calculate the total cost, we have learned through the past lecture that the total cost is the summation of the fixed cost plus the variable cost. You see this yellow line, it is the fixed cost, it is a steady amount. It is steady amount no matter what is the output or the production or the sales level. However, the variable cost, it's a cost that increases as the production or the output increases. So you see this blue line and the yellow line. These are my fixed and variable costs. Now we agreed that the total cost is their summation. So let's begin from period 0. You see the line related to the total cost is the red one. Okay? At time 0, my fixed cost, let's say, is 10. And the variable cost is 0. So what will be the summation of 10 and 0? It's going to be 10. So the red line will start to appear. As you go through the levels of production, the variable cost will increase. So this means that the total cost will increase as well. So I will be able to draw the total cost line. Then you will have to draw the green line, which is related to the total revenue. What is the total revenue? I need to calculate the quantities that I have sold, okay, and the selling price of each quantity. And as you sell more quantities, you will be able to make more total revenue. So this is the green line. The intersection now of the total revenue and the total cost is the break-even point. So you see, this is how we draw the the break-even point. You must understand that this is the quantity that needs to be produced so that the costs equal to the revenue. At this quantity, if I manufacture this quantity, let's say it is 10 units, at this quantity I have no losses, I have no gain. At this point, total cost equals to total revenue. So if I want to start generating profit, I must increase the production to a quantity which is greater than this quantity. So this is the meaning of the break-even point or break-even quantity. Now suppose that for this produced quantity Q1, the selling price per unit was $2. So what will be the total revenue? The total revenue is the price per unit times the quantity being sold. So I will start drawing the total revenue line at 0. Since no quantities are being sold, then the total revenue is 0. As the quantity increases, the total revenue will increase. So you will see this is the break-even point. So I need to sell Q1 quantities at price of $2 each to break even. Now what if I decided to increase the selling price per unit? For example, I will assume that the total revenue instead of the selling price per unit instead of $2 is $3. What will be the total revenue? What do you expect? Will the slope of the line becomes more steep or less steep? What do you say? Let's see here. If I decide to change the selling price into $3, this is how the total revenue line will look like. You see, the slope is becoming steeper. So this means that I'm gonna sell less quantity to break even because the price has increased. So the quantity to be sold is less than quantity 1. This is quantity 2. On the other hand, if you decided to lower your selling price, let's say it's gonna be $1 per unit, this means that the total revenue line will look like this, meaning that you will have to sell more quantities in order to break even. You see, quantity Q3 is greater than Q1 because the selling price at Q3 was less than the selling price at the break-even point at Q1. So if I want to determine where is the profit area, it's gonna be this area beyond the break-even point. And if I want to sell less quantities than the break-even point, then you will be encountering losses. You need to know that calculating the break-even point is very beneficial to you before you start any project, because it gives you an idea whether this project is going to be profitable or not. Is it risky to do it? Let's see together using this example here. Tom wants to hire an ice cream van for an afternoon at a summer festival. He will rent the van for $100, and he calculated the cost of raw material to do the ice cream, and he assumed that it's gonna be 50 cents per one ice cream. He thinks that it's gonna be a good selling price if he sells each ice cream for $1.5, and at this price we have to calculate how many ice creams must he sell to cover his costs or to break even, because calculating this will help Tom to decide whether this is a good idea, shall he go for the project or not. Now, considering that Tom is renting this van for only one day, so he thinks that the maximum number of ice cream that he can sell in that day is maximum 300 units, and he's proposing that he's gonna sell each ice cream by $1.5. So the maximum revenue he could get is $450. So you see, that's how we have set the horizontal and the vertical line. The horizontal line represents the number of units sold, so it can range from 0 to 300, and the y-axis is corresponding to the revenue. So he can make revenues from 0 till $450 maximum. Now we want to start drawing the break-even chart together. First of all, we have to begin with the fixed costs. What are the costs included? he only has to pay for renting the van, which is $100. So this is a fixed cost. It will not change no matter how many ice cream he will sell that day. So he's gonna pay this $100 even if he didn't sell any single ice cream. So that's why it's referred to as the fixed cost. So how do I draw it? I draw a horizontal line at 100 on the y-axis because this is the cost that he's gonna pay, $100, and it's fixed, so it's a horizontal line. Now I want to draw the line related to the variable cost. But first of all, I need to determine what are the variable costs included. This includes the cost of raw material and the cost of direct labor. Here in this case, we don't have direct labor because Tom is working himself, but he estimated that the raw material cost for each ice cream, it's gonna cost $0.5. So this is the variable cost per unit. So if we said that he's not gonna sell any ice cream, this means that the variable cost line will begin from point 0. However, if he decides or if he got the chance to sell 100 units times $0.5, so this is $50 as a cost. Now, if he got the chance to sell 200 units per day at a cost of $0.5 each, so 200 times half, this is gonna give you $100 cost. So if I determined these points, I will be able to draw the line of the variable cost. Now I want to calculate the total cost. We agreed that the total cost is the summation of the fixed cost and the variable cost. Now I want to get the total of these two lines together. How do I do it? First, I stand on the 0. At point 0, here at this corner, what do I have? 0 variable cost plus 100 fixed costs. So what will be the total cost? It will be 100. So the line of the total cost will start from this point at 100. Now if I want to look at the point on the x-axis related to the 100 units, I know that the variable cost is $50 as we calculated it previously. If I draw a horizontal line at this point where the quantity of ice cream sold is 100, to intersect with this yellow line, it is how much? It is still 100 because we said that the fixed cost is constant at $100. So what is the summation of 100 plus 50? It's gonna be 150. Now if you go to the point related to quantity equals 200 units, what is the amount of the fixed cost? It is still 100. And the variable cost as well, we agreed that it is 200 times half, so it's again another 100. So the total cost at this point will be 100 plus 100, it is equal to 200. So if I want to draw the line related to the total cost, it will look like this. Let's see. So you see, this is the line related to the total cost. You can see that it's parallel to the variable cost. However, the only difference is that it doesn't start from 0, it starts from the value 100. Now, in the same way, I'm going to calculate the total revenues. Total revenues is the quantity sold times the price. So if I didn't sell any ice cream, the total revenue will be 0. The selling price of one ice cream was $1.5. So if you sell 100 ice cream, times 1.5, so the revenues will be $150. If you sell 200 ice cream times 1.5, so the total revenue will be $300. So if I join these 2 points, this is gonna give me the line related to the total revenues. Now I just need to determine the break-even point. It is the intersection of the total revenue with the total cost, and you can see that it is the point at 100. So this means that I have to sell 100 ice creams in order to break even. This means that I didn't make any profit and I didn't lose as well. If Tom will sell more than 100 ice cream, he will start to generate some profit. So this is my break-even point, this is the loss area, and this is the profit area. So if I want to translate the results that I got when I draw the chart related to the break-even point and translate it into a formula, the formula will look like this. The break-even point equals to the fixed costs over the selling price per unit minus variable cost per unit. Let's apply this to Tom's example. You will see that the fixed cost was $100, selling price was $1.5 per each ice cream, and the variable cost per each ice cream was $0.5. So 100 over 1 equals 200, and this is the break-even point that I got by drawing the charts. So you can get it in a quicker way using this formula.